Hey guys, welcome back to the next video. In this video, we are going to look at another perspective of your workload management, which is the node and pod affinity. Now, in this video, we are going to work with firstly with the node affinity, and then we are going to relate it with the pod affinity. So I will be telling you or talking about how both node and pod affinity is different from one another. Node affinity talks about selecting a node based on a specific scenario. For example, over here is a deployment. In this deployment, we are creating 3 replicas, and it is replicas so is matched by the application name, which is my app. And if you see the template for this application, my app, right? So we are setting up an affinity over here. Affinity is nothing but a way we can affiliate an existing resource with this particular deployment. So to affiliate, we are using a syntax over here called node affinity, and under that we are using require during scheduling, ignore during execution. So now there are like a couple of options over here. Firstly, we will unravel this option, and then we will see the other option on another video. So don't worry about it. So I'm going to cover that as well. So required and preferred. So these are the 2 options which is there. So as of now, we are covering required. So later point of time, we will look at preferred. So required during scheduling. So what happens is that what this word is saying that you need to look for the node affinity when it is actually scheduling this particular pod. All right. Now, what it needs to use as in towards the node affinity is the node selector term. So it is using another function over here called node selector term, which actually matches the expression, and it is looking for a key called GPU, and an operator value is true. So as we have configured this on the previous example also, now this worker 2 has this GPU true. Let's just say for example, and this particular pod gets created. All right, because when you apply this, it goes to the API server, then it loads this configuration on etcd, and then goes to the API scheduler, and then schedules this using kubelet. And when it schedules both worker and worker 1 and worker 2, worker 1 doesn't have this particular label. So obviously it is choosing to choose this particular worker, which has this label of GPU colon true, or GPU equal to true. And there it basically creates the pod. So that is basically what is called as a node affinity. Now, when you talk about pod affinity talks about basically checking for other pods. For example, over here, in this example, let's just talk about this. There's another deployment happening with the 3 replicas, and let's just say this is a different deployment. For example, this is a CentOS 1. So this is a different deployment happening altogether. So needs to create another pod. Now, how this pod or where this pod will be created is based on this particular match. Okay, so what it says is like affinity, pod affinity. So here we have given node affinity over here. And we have given the similar option, which is required during scheduling, which means that you need to pass this during scheduling. So the other option is preferred. Preferred means like it is preferable, but required means it has to do it. Okay, so it has to look at this parameter while scheduling. Now, there's another function called over here called label selector. So this here, just like a node selector term, we have something called label selector over here, which again uses match expression here for key, app, and then my app. So what it is looking for is a pod name which has the application name as my application. So if you see that this particular pod has the label, so here we have given under template label app colon my app. So it looks for this, and it won't be scheduling this pod on the worker 1. Why it won't be scheduling? Because there is no pod created on worker 1 with the label of app my app. So what it will do, it will go to the worker 2 and schedule the pod there, because it sees that it has a pod with that particular name already existing on worker 2. So it would choose worker 2 rather than worker 1. So a pod affinity talks about how it's going to relate with the pod more than a node. Okay, a node affinity talks about how it's going to relate to the node rather than a pod. So this is what we are basically going to see on the hands-on session. In the further down the videos, we will see what is preferred option and how the preferred is different from required. And you obviously know the difference when I say preferred and required. So that itself tells you clearly that what is this. And then we are going to talk about anti-affinity as well. So how you can overcome the affinity, how you can go not in, as in like it's not part of this. So just like how affinity works, anti-affinity works in the opposite way. So we're going to see that as well in another architecture diagram and then hands-on towards that. Thank you again for your patience. I'll see you on the next video.